So maybe you could define insulin resistance, describe its relationship to elevated blood sugar or to blood sugar in general, and then discuss the relationship between the elevated blood sugar, insulin resistance, and aging as such.
So think of the muscle maybe as a balloon. And the balloon is the only place where you can put air. In this analogy, air is the glucose. So there are some balloons that are very easy to blow up. And you can put the glucose into the muscle cell, you can put the air into the balloon quite easily. You don't have to blow very hard. But imagine a balloon that's very, very difficult to put air into. And at some point you can get air into it, but you have to blow much harder. So how hard you have to blow is the amount of insulin you need to put the glucose into the muscle. At some point you will not be able to do that. You can't blow hard enough. So again, just thinking about this in terms of physiology, glucose is a molecule that needs to be regulated very carefully in our bodies. Too much and too little is catastrophic. And so the body does a great job of trying to take excess glucose out of the circulation and put it into muscle cells. By the way, just to put this in context, Jordan, a healthy person has about 1 teaspoon of glucose floating around all of their circulation at any moment in time. A person with
1 teaspoon.
1 teaspoon. A person with frank diabetes has 2 teaspoons. That's the difference between healthy and nearly dying, right? It's profound.
How many teaspoons of sugar are in a bottle of Coke? It's 30, I think, or 35.
About 8. About 8 teaspoons in a small
I guess I was thinking of a big, maybe I was thinking
in a big 2 liter. In a big 2 liter, it would probably be about that. Yeah. Yeah.
Right.
So our body is amazing at doing this, but it's a very delicate dance between how much insulin do you need to make that happen. And the canary in the coal mine of insulin resistance is after a person is challenged with glucose, even if their glucose levels normalize, they needed supranormal levels of insulin to do it. That's the initial blowing too hard on the balloon.
So when you develop insulin resistance and that progresses to diabetes, you literally can't produce enough insulin to get sugar into the muscles.
That's correct. Eventually, you cannot make enough insulin. And this is complicated by another factor, which ties into this cascade of metabolic disease, which is eventually fat starts spilling out from the cells that we are meant to use to store excess energy, which are our actual subcutaneous fat cells. And that fat starts spilling into other areas where we're not supposed to have it, into the muscle, which is what's causing the actual mechanism of insulin resistance. It's the fat in the muscle that is preventing the insulin signal from being heard effectively by the muscle cell. It also expands into the liver. That's what's called fatty liver disease or non-alcoholic fatty liver disease. The fat starts to be deposited in the pancreas where insulin is made, and that creates an inflammatory environment to the insulin-producing cells. So now you have the double whammy. You need more insulin, but you can make less of it because of the inflammation. And this thing very quickly spirals out of control, and the end state is type 2 diabetes.